Hello, it's Keith here, and this is the final episode of the Grime Z80 project. Now, if you've been following, I've been spending 7 days trying to create a game that runs on 11 different systems. And well, how have I done? Well, I think I've done quite well. You can see a variety of different systems here. I've struggled to even get them all on the screen, and the game is working on all of them. And as I've said before, this is one common piece of code that is running on all the systems via drivers that I've written for the different specific hardware of the platforms. So let's take a look at them. I've got a little checklist here so that I make sure I go over all of the systems I promised I would do. So let's have a look at the Spectrum first. So we'll just unpause this. Now you can see I've created a new option which says press K for Kempson. This is Spectrum only, and it's because if I read from the Kempson it can cause some problems on systems that don't have the Kempson port. So if I press K, you'll see that disappears, and now joystick control is enabled. And let's start the game. And you can see I've changed it from yesterday, so we now have some nicer graphics for the two colour systems, the black and white systems that is. So they are now optimised for the simpler screen like this, but the game is basically the same. And I've tried to make the speed match on all the systems now by putting pauses on the systems with very small screens, and on the case of the MSX2 I've actually disabled the animation of the non-moving objects because it was too slow. If I was going to spend more time on this project, one of the things I would do is I would write a new driver for the MSX2 that would work in the same sort of tile-based way as on the MSX1. Now the MSX2 isn't a tile-based system, but I think it would get a speed boost if you treated it as one, because you could copy in 8x8 blocks, and it's really copying of areas of the screen that the MSX2 is powerful at. It's quite weak at this bitmap based access that I'm using here. So anyway, that's the Spectrum done. So let's take that off our little list here and let's have a look at the next one, the CPC. So again, the CPC did have some quite unpleasant graphics yesterday because I hadn't done the proper 4-color optimized ones. And you can see it does now have a nicer palette. So the top colour is effectively white. It is white on the CPC. On the Enterprise 128 it's slightly off white, it's slightly green. The Enterprise has a slightly better colour palette than the CPC, so that is the difference. But they are actually using the same palette definitions, and the palette definitions are being converted by some code that I've written and I will be covering in my tutorials. So you see the design I've gone for here is green, blue and white, and I've used the green primarily on the outer blobs, the blue on the inner blobs, and then the white for the seekers. So each tile is almost one colour. There is a slight amount of a second colour being used, but I've kind of prioritised one colour to make it more vivid. So that's the Amstrad CPC version. And one thing I should say is you can actually build the game for the CPC Plus. It does work, because the only difference is the if I just remove this and run again, you'll see that now the text is actually a slight shade of green, because we're now using the CPC Plus color palette. Ideally, I suppose we would auto-detect whether the CPC or the CPC Plus was in place. I don't have the code to do that in my tutorial code. Chibi Akuma's the game does do it, but the code I use there is a bit sort of designated for the memory layout of that system, and because you have to page in alternate banks and test if they worked, it is quite memory layout specific, the code you use. So I'm not happy that it's as a stage to put into my tutorial code, which is what this is based on. So there's the CPC working. So let's have a look at the MSX1. Here it is. So now I've written that improved code, the speed is much better now on the MSX1, of course, but that's been there for several days. What we've added today is the proper sprites, and these are again the Spectrum sprites, 2-color. I just made a few tweaks to because the MSX1 has improved palette options. It can do 1 color per line. I've just made a few tweaks, like the inside of the green tiles are slightly they're darker, whereas on the Spectrum they're black. And so there was a few very slight changes, but not too much. But yes, it plays very nicely. Let's remove that from our list, and let's check out the MSX2 version. So here's the MSX2. Now we have animation on the front screen, but you will see already it is running significantly slower than the MSX1 version. Now the game's relatively okay, but that's only because if you look at the tiles you'll notice they're not animating in the same way. And that's because, as I say, the graphics driver that I've written for the MSX2 is really only it's only really suited for sort of text adventure stuff where, you know, if you were drawing a bitmap to the screen you weren't trying to update it. So you know, what I'll do next I'm not sure. Or, as I said, one option would be to create an emulation of the tile map functions that the other system, that the Game Boy and the Game Gear and the MSX1 are using, but even that's not going to be ideal because that, again, that isn't really how the MSX1 wants to work. So I'd say I'm undecided on that. It might be something I pursue if I've got spare time, but it would be quite a bit of work. And as I say, if you really want to make the most of the MSX2, that's not what you would want to do either. So okay, the MSX2 is working anyway. So it's not ideal, but it's playable. So let's have a look at the Sam Coupe. So the Sam Coupe is also a 16 colour system, but it's much faster than the MSX2, and there's two reasons for that. Firstly, it's got a superior CPU, it's a 6 MHz CPU, and secondly, it is a bitmap screen. So you know, the way I'm sending the data to the screen is much more in accordance to what the screen is expecting, whereas on the MSX2 I'm kind of tricking the screen into working as a bitmap screen when really it's not optimized for that kind of method of access. But anyway, you can see the game works just fine on this system, and it looks quite nice. So that's Sam Coupe done. So let's have a look at the Enterprise now. It's effectively on the Enterprise version. On the Enterprise version, you are effectively seeing the same thing as the Amstrad CPC, just with that slight colour change on the top colour. The gameplay is identical because, as I say, everything else is basically the same. The Enterprise does have a very, very slightly faster processor. The Amstrad CPC one runs at about 3.6 MHz. The Enterprise runs at 4, but apart from that, there's no difference. So graphically, it's all going to be about the same. So yeah, seems to work fine. So the lowly TIE 83. Let's have a look at that. So as I said before, the TIE 83 doesn't have any sound capability, so there is no sound. But you know, the game. If I don't have a TIE 83 cable, I do have a TIE 83, but I don't have the cable to copy to it. But I'm assuming, you know, this will be reasonably playable on the system. It does. It's quite fast. You know, it's playably fast. The screen blur, because I've disabled the animation, doesn't seem too bad. It's certainly no worse than commercial games I've seen, because it does look like this emulator is emulating the screen warts and all with any screen blur that system suffers. So you know, it seems okay. Quite relieved, to be honest, that worked, because I was concerned that originally I was having trouble making larger ROM files for the TIE 83, and at first I thought it was a limit of the TIE 83, but it actually turned out that it was a bug in the compiler. The compiler was doing its memory allocation wrong. It was a bug in the C code that made it. So fortunately it's open source, so I fixed the bug, and that's how I was able to make a ROM as big as that with its own built-in font and sprites and things. So I was quite impressed with the TIE 83 really. So here's the Game Gear version. Oh, and I'm using the wrong keys again, so I'm getting killed. So I had to slow down the Game Gear and the Game Boy versions because the screen was so small and the hardware was doing all of the dirty work of copying the graphics bitmaps. They were actually too fast. So there's actually a delay doing nothing. But you know, say it looks quite nice, plays nicely. There we go. So that's the Game Gear out of the way. Let's fire up the Master System. As I've sort of said a few times, they're effectively the same system. It's just the screen size is smaller and the Game Gear has a different palette definition. I am working on now some tutorials I'm going to be doing covering the Game Gear and the Game Boy and the Master System and the Game Boy Color, discussing the basics of how they work, because one of the reasons I wanted to do these these episodes of this programming project was I wanted to get to a point where I felt I was able to understand enough about the Game Boy and have validated that experience, shall we say, by proving it. I knew what I was doing by making this, so that I could start covering them properly in the tutorials. Because, as I've said before, I think if you program these things right, like you can see here, you can spend the same amount of time as you'd spend writing one game, but then you can make that game run on multiple systems, and so you've just increased your potential sort of consumer base, shall we say. So I don't think it would be possible for me to write a game like Chibi Akuma's on this many systems at this stage, but I could probably write something significantly more advanced than this and make it work on all of these systems. Obviously, it would take a lot more time, and who knows, maybe one day in the future I could actually consider writing a far more advanced, sort of arcade class game like Chibi Akuma's was on all these systems, but there would be a lot more groundwork needed to get all of the systems working in similar ways, so that you don't end up writing the code over and over again. But anyway, they say this works fine. So we've covered the SMS and the Game Gear. So let's see the Game Boy. Well, here it is. So the sprites on this have been tweaked again. They're actually slightly different from the 4-color systems, like the Amstrad CPC use almost the same sprites, but this is using 3 colours per tile, whereas, as I said before, because the Amstrad CPC, I was trying to prioritise a single colour. Generally there were only 1 or 2 colours, but certainly the majority of each tile was only 1 colour. But on the Game Boy Color I'm using all 3, and on the Game Boy is using the same sprites as the Game Boy Color, it's just missing the colour information. So that the palettes I've defined for the Game Boy Color, they match what the Game Boy would be showing. So the bottom colours are always black, and the second colours are always dark, and the third colours are always light, and the top colours are always white or something equivalent to white. So that works okay. And then finally the Game Boy. Now the Game Boy Color does have more advanced functionality. It has a faster processor, extra memory, and extra tile banks. But I'm using you have to sort of switch in the extra tile bank memory to change the palettes. But apart from that, I'm not using any of the functionality. I actually had to slow the game down on the Game Boy to make it playable. So it didn't make sense turning on the faster 8 MHz processor, because it's already too fast. So there's not really any way. Well, there wasn't any way in this game to use the extra tiles that would make sense, because I wanted to make it work on the Game Boy. So, really what you're seeing here is the Game Boy Color version, just without the palettes being turned on, which, as I say, it's no great loss. The game is perfectly playable without it. It's just, if you've got the Game Boy Color, then, it's an added bonus. One thing I should point out with what you're seeing here, I've only tested these on emulators. I don't have the hardware to test on a Game Boy. I have Game Boys, but I don't have cartridge emulators. And one thing I should point out, if you were trying to run these on real systems, the real systems do have checksums and other checks on the ROM settings. Now, I've not tested them on there, so while the game code does seem to run on these emulators, you have to bear in mind that there may be reasons why they won't work as well on real hardware. It was out of the scope of what I was trying to do with this project. If I was going to fully debug these and test these and release these as commercial products, the testing time would be, in this case, many times what the actual development was. I'd be still, Chibi Akuma's, the testing was 6 weeks, and the development of the game only took 6 months. So it was a huge amount of time. The testing took longer than writing 2 of the levels, basically. So with this many platforms, testing it to say, yes, I'm confident this is going to work on every system out there without any bugs or without any compatibility issues would be just it's not within the scope of what I was trying to do. I was just trying to make code that worked on all the systems. So anyway, this is the end of this series. As I said there's going to be one final episode, which is going to be a summary where I will go over the source code and discuss what each bit does in the final version of the code. The source code is available for download. The game is, of course, is also available for download, so if you're interested, just go ahead and download them. The source code will be included in my sources.7 zip download once it's released publicly. There'll be a special link for the patrons until then, because I'm still just integrating everything and tidying it up to make sure that the updated code isn't causing problems for my tutorial code and things. But anyway, I hope you've enjoyed this series. If you want to play the game, feel free to download it. If you don't want to play the game but you want to do some programming, then great, download the source code and maybe you'll be able to pick some stuff up that you can take advantage of. But either way, if you think this kind of stuff's interesting, please follow my channel, because the tutorials are going to be ongoing and they're going to cover now the 4 games consoles: Game Boy, Game Boy Color, Sega Master System and Game Gear, at the same time as I've been following the computers, because now I'm at a point where working on all these systems is sufficiently clear to me that I can say with confidence, I can give instructions with confidence and feel that I'm giving a good advice that is worth following. Anyway, I hope you've enjoyed this. Thanks for watching and goodbye.